In this video, I'll explain to you the 3 different degrees of freedom of motion. So, degrees freedom of motion. So, there is going to be one for each state of matter. So, solids will have a degree of motion, and that is vibrations. Liquids will have a different state of motion, and that is rotation. And it will also have its vibration. Let me fix that. Yeah, so rotation, vibration. And then gases, a gas, will have vibration, rotation, and translation. And then rotation and vibration. Now let's talk about each separately. So we first mentioned solids. We said that solids have a degree of motion called vibration or vibrational. And what really is happening is that the molecule is stretching. So we said that when I drew this before, solids are all encompassed together. So all they can do is vibrate. And what I mean by vibrate is they kind of stretch. So let's a molecule. There we go. We have 3 atoms, so we have a molecule in this case. And what is going to happen is that when it vibrates, the length of the bond will increase or decrease. So when it vibrates, it'll kind of end up, let's say an example, let me draw it like this. So this bond right here clearly stretched or vibrated. This one too, but this one became longer and this one became shorter. And there are different names for that, but that makes it too specific. All you have to know, in a solid, it vibrates. It doesn't rotate or translate. Now let's talk about liquids. So liquids. A liquid will have vibration like a solid, but it will also have rotation. Or yes. And when I drew the liquids, we said that they weren't as tightly packed as the solids were. So I mean, if you think of it, they have more freedom. They can move everywhere because they just occupy the volume of the container. So they can kind of like move around, and instead of just stretching or vibrating, they will also rotate. So something like this would happen. And we will have here and here. So it's not just the length of the bond, the orientation. So they kind of rotate in between each other. They just rotate, and that's because they occupy the whole volume of the volume of the container they can reach, of course, and can move around. Like just by looking at a liquid, you can see it kind of has more motion, more freedom to move around. It's not as tightly packed as solids are. Now the last one is what occurs in gases. So in gases, we said we will have vibration, we'll have rotation, and we'll have translation. So when we had a gas, let's say it's covered so it doesn't diffuse, we said that it occupies the whole volume of the container, not until where it can reach, so it occupies the whole thing. And we also said that the particles kind of move around. That is what we call translation. In this case, the whole molecule is going to move. Let's say to this location. So it moved there. The whole molecule moved, and because it can rotate, it also rotated, changing its orientation. And well, that's what gases do. They kind of move around through the whole container. And well, I found a picture just to summarize everything. It's this. So you can see in solids, they kind of bend, they vibrate. So the length of the bonds change between them. When it's rotation, you can see how it just flips around, or in this orientation too. It just changes its orientation. And then finally, in translational motion, that's what happens in gases. The whole thing just moves to a different location. Let's say from A to B. So it's translating from a place to another. And those are the three different degrees of freedom of motion.